we are doing problems from this review. Alright, so these are all 17A review, 17B review. Alright, so let's do tell you what, let's start with number 5. We'll start with the earlier one first. So here we go. We got the square root 192 y squared. And if you read the instructions, make sure that you do read the instructions, okay? Because sometimes it may look like a problem that you think it is, like that rationalized denominator, rationalized numerator, okay? Make sure that you do. That's not one of these, but just make sure you read it. Just says simplify, and basically that's it, okay? So that was the instructions for that. So what do? The square root of 192. What do you think? Take 192 and break it down. Okay, yeah, 2 goes into it, right? Because it ends in a 2. It's an even number, so you know 2 goes into it. And you said, what, 96? So let's take 192. Let's go off to the side here and break it down. So it's 2 times 96. All right, let's break it down some more. Can you take the square root of 96, come out even? Nah. So that's a 2. Let's break down 96. 48 and 2? Okay, good. All right, because again, 2 goes into 96, right? All right, what about 48? We could probably break it down a little bit better than that. 6 and 8, right? Would you agree? Tell you what, we can do this in our head, can't we? Let's break down 6 in our head. So what's 6? 2 times 3. Let's break down 8. What's 8? 2, 2, 2. Agreed? So there's that 2, and all that's 48, but don't forget what? One more 2. So if you want to break it down like that, that's perfectly fine. So now what do? Let's group them, right. It's a square root, so we group them into what? Groups of 2. So let's do that. So there's one group of 2. There's another group of 2. There's another group of 2. All right? Everybody with me on that? So I tell you what. I guess I should have just put them in here, shouldn't I? There's 2. Or if you want to, just do it like this. 2 times 2 is what? 4. And then another 4. Then another 4. Make sense? See what I just did? Okay, I made that 4, that 4, that 4, and then you also have a what? A 3. And you got a y squared. Alright, so now we can do this. Now it's really simple once we've done all that. That was the hardest part of this whole problem, was just breaking it down like this. Then you group it into 2s. That wasn't hard. But now you just do this. It's the square root of 4. What's the square root of 4? It's just a 2, isn't it? It's a whole number 2. It's not a square root of 2. It's just a 2. Alright, so I'm done with that. What's the square root of this 4? It's another 2, right? And they're being multiplied. Now remember, these are all outside of the square root once we take the square root of them. Then we take the square root of this 4, which is 2 again. Square root of 3 you can't do anything with, so that's going to stay inside the square root. What about this? What's the square root of y squared? It's just y. And now, what's left in that square root we said? The 3. Multiply them and we're done. 2 times 2 times 2 is 8y square root of 3. There you go. I guess there's a couple of different ways you could do this. I mean, you could have found another number that went into 192. You know, you could have said 4 goes into it, or you could have said like 16 goes into it, right? I guess 64 goes into it as well, right? But those are not numbers that just popped in my head, right? The first thing that pops in my head when I look at that number, I see it ends in a 2, so I think 2 goes into it, right? So I do a quick little division. You got a calculator if you can't do it in your head. It's 96. You look at 96. Maybe that's not a number that just pops in your head, right? But it does end in 6. So you're like, okay, 2 goes into it. So I take 2 into it. You follow me? And then you get 48. And you're like, okay, 48. Do I have to keep going 2, though? Nah, because you could probably split it a little bit better than that. So I'm thinking, okay, 6 times 8, right? So that's what I did. I went, there's the 6 and there's the 8. Or you could have gone, what, 16 times 3? That would have worked as well. Maybe that's something that just doesn't pop in your head, though. That's fine. Just break it down into its primes. Whatever way is the best way for you to break it down into its primes. That's the easiest thing to do. And then why did I put 4s in here? Because I grouped these together. That 2 times 2 is a 4. That 2 times 2 is a 4. That 2 times 2 is a 4. Everybody see that? Or you could have done this. You could have just multiplied them all together. 2, 2, 2, 2, 2, 2. Oh, 6 of them. What is that? 2 times 2 is 4, times 2 is 8, times 2 is 16, right? And then times 2 is what? 32, then 64. And what's the square root of 64? It's what? It's 8, isn't it? right? So again, there's all kinds of different approaches that you could have taken with this. I didn't, I'm not, well, I almost did go through every approach probably, but anyway, there you go. That's how you do it. Number 7. So 7 then 11, if I can remember that. So let's do number 7. All right, this same kind of deal, pretty much the same. This is k to the 7th and q. I just hate when they put a q in there. To the 8th. All right, let's think about this. Let's think of 125. Let's come over here to 125 and break that down. Well, it ends at a 5, so obviously what divides into it? 5 does. And we've used this number before. You should know it. 5 times what? 25, right? Now, you could break 25 down if you wanted to, but you already know what the square root of 25 is, don't you? All right, so let's put that in here. So I've got, let's do the 25 first. Is that all right? So 25 times 5. You okay with that? And you know what we're going to do in the next step, right? We're going to take the square root of 25 and make it a 5 out in front. But let's just keep going. What about k to the 7th? Can't take the square root of that because it's an odd exponent, but I can break it down. I could break it down into what? I could go, if you wanted to, k squared, and then another what? K squared. That's 4 of them, right? And then another one, and then just a k, right? And that's 7 of them. If you wanted to do that, you could. I'll tell you what. I'll show you a little bit of a shortcut. You could just do this. What's the largest even power you could get out of k to the 7th?
K to the 6th.
K to the 6th, right? And then so it's k to the 6th what? Times k. Now think about this. It's the square root of k to the 6th. I don't want to mess you up too much, but remember what square root is with an exponent? It's to the 1/2, isn't it? So I want you to just see this. This is actually kind of easy. Okay, and I kind of like you looking at it this way. You could have done what we did earlier. All right, that would have been okay. But it's takes a little too long to do it that way. If you would have realized that k to the 7th is the same as k to the 6th times k to the 1st, you could do k to the 6th, because what's the square root of k to the 6th? Isn't this the same thing as square root? Why in the world did I write it like this? Because it's easy to see that rule for the exponents. What's the rule for the exponents? Exponent take it to another power. Anybody here? We multiply the exponents together, okay? So what is that? It's k to the 3rd. So what's the square root of k to the 6th? It's what? K to the 3rd. All right? What about q? We could do the same thing with q to the 8th. Instead of breaking it down into q squared, q squared, q squared, q squared, instead of doing that, which is a little time consuming, we could look at this and say, oh, it's an even exponent. I can take the square root of an even exponent. Basically, what do I just do to the exponent? I take what of it? Take half of it. All right, so if I take the square root of an even exponent, all I'm doing is taking half of that exponent. And this is the reason why. You don't have to write this out. I'm just showing this as the reason. You're probably thinking, why did you take half of it? Well, it's because of this right here. Because the square root is the same thing as to the 1/2 power. Seems like I lost some of you guys by the looks on your faces. But look, just remember, if you take the square root of an even exponent, all you got to do is take half the exponent. So it's going to be k to the 3rd. Take half of this exponent. It's going to be what? Q to the 4th. And I just showed you the reasoning here. All right, so let's do this. What's the square root of 25? It's just plain old 5. Oh, so we're done with that. Let's leave this to the end, okay? Because I can't really simplify that. Let's do this stuff in here. What about k to the 6th? We just finished talking about that. We took all this time to do this. What's the square root of k to the 6th? K to the 3rd, right? So we're done with that one. K to the 1st is just going to stay inside of there, so I'm just going to keep that right there for now. What about q to the 8th? The square root of q to the 8th? Q to the 4th, that's right. Again, we just take half of the exponent. And why do we take half of the exponent? Because of this thing right here. All right, so that's all the stuff we took out of the square roots. Now we got to figure out what's left inside of the square root. Well, we got a 5 and we got a k. So I just put it right there. And that's it. Does that make any sense? You see why I took half of the thing? Now, again, you could have gone k squared, k squared, k squared. All right, and then grouped them together, right? Brought out one of the k squares. If you bring it out of the square root, it's going to be a k. Then another one's going to be a k. Another one's going to be a k. You're going to end up with k cubed anyway, aren't you? But that's just, it's too long of a process. Okay, let's streamline a little bit, make it a little bit easier for us, and just say, oh, what did we do? We just took half of that exponent. Make sense? Only if it's square root, right? All right, because remember, it's kind of like, it's like a second root, right? Now, if this was a cube root and you had something that was divisible by 3, for instance, what if it was this? What if it was the cube root of k to the 6th? That's supposed to be a k. Let's make it look like one. What if you had that? That's going to be, right, oops, that's going to be, watch, k to the 6th to the what? What's the same thing as the cube root? It's the 1/3, isn't it? So if you have something that is divisible by 3, you can do the same thing with a cube root. Okay, if it's divisible by 4, you can do it with a 4th root. Same thing with 5th root and so on. Okay, and you're right. 6 times 1/3 is 2, so that's just k squared. All right, so it's just a little shortcut. All right, so you don't have to write it all out. Anyway, I hope that makes sense to you. Now we're doing 11, right? All right. Start with a clean slate here. Number 11. All right, this just looks like FOIL method, doesn't it? 9 minus the square root of 13, and then the square root of 6 plus the square root of 6. I see something I'm going to do right away. I don't know if you saw it. Now, I said, when I first glanced at the problem, I said FOIL method. But then I took a closer look at it after I looked at the second part of this. Is there something we can do to simplify one of the parentheses before we actually multiply together? Square root of 6 plus square root of 6, you're right. Okay? Did anybody notice that right here? That's the first thing that popped in my head when I saw this. I thought, oh, I can add those together, right? They're like terms. So let's do it. Remember order of operations. Please excuse my dear Aunt Sally. P was parentheses. Always look at the parentheses, see if there's something you can simplify. Now, could you have just done FOIL method on this? Absolutely, you could, and you still get the right answer. But I think it might be a little bit easier if you just change this right away to what? Oh, it's not a 3, it's a 13. It's what? 2 square root of 6, right? If I add those together, one of these plus one of these is what? 2 of them. Good. And so now I can just do a regular distributive property with this. All right? I don't know if that was any quicker or easier, but that's what I looked at. That's how I saw it. I don't know, kind of like that way. So let's do this. So 2 square root of 6 times 9, so that would be 18 square root of 6, minus 2 square root of 6 times square root of 13. So I got a 2, and then I got a square root of whatever 13 times 6 is. What's 13 times 6? That's 18, that's a 7. 78, is that right? Now 78 won't simplify. All right, and I know that right away because what's 6? 6 is 2 times 3 times 13. So 78 is 2, 3, and 13. Can I take the square root of anything in there? Can I take the square root of 2, 3, or 13? No, nothing groups together. So square root of 78 is as simple as I can get it, and I just leave it just like that. I kind of like that way right there. Now you could have distributed if you wanted to. Do you want to do that just to see? Let's do it real quick. It shouldn't take too long. So it's that, and it's this. So let's do the FOIL method on this without simplifying this, and let's see if it's any easier or not. Who knows? It might just be the same number of steps. I don't know. So what do we got? 9 square root of 6. Right, that's the first. The outside is another 9 square root of 6. The inside is minus square root of 78, right? And then the last is negative square root of 78. Just like that. We good? Now you got to add like terms though. So you add these up. 9 of these plus 9 of these are 18 of them. Okay, minus 1 is minus 2 square root of 78. So I don't know which way you like better. I really don't have a preference. But I got the same exact answer, didn't I? Looks about the same number of steps, doesn't it? All right, I wrote the problem down, did this step, got the answer. Wrote the problem down, got this step, got the answer. So really, in effect, it probably wasn't any easier to do it this way, but that's what I saw right away. I just saw that, and I thought, hey, just add them together. All right. Anybody write down what we did from B? What were the ones? I remember 5. Or, no, 1, right? when there's a 1? Okay, so let's go numerical order. Was it 1, 5, and 7? Is that, or was it just 1, 7, 9? Okay. All right, so let's do number 1. Everybody's favorite. What's that? I was thinking about that for tonight. I think I probably will do that. Yeah, you can always do it on a separate sheet if you want to. It doesn't have. You don't always have to write on these worksheets. If you want to do it on another sheet of paper, if you don't have enough room on here, it's always fine. I never have a problem with that. All right, what are you doing? You're adding fractions together. So the first thing you want to do is think about adding fractions is finding a common denominator. But before we do that, we look at our denominators. Are they really ready to find a common denominator just yet? No. We have to simplify the denominators. It's going to make it so much easier for. In fact, I wouldn't even know what to do if we didn't simplify the denominators. I really wouldn't. So what do we do here? Let's simplify that, right? And we'll simplify that right there. So let's take the square root of 20. Let's just do that off to the side. I think we did that the other day, didn't we? Yesterday? Yeah, you should be able to just do that in your head, I think. Don't you? All right, but let's write it down. Let's write down what you should be doing in your head. So I'm looking at square root of 20. I'm thinking 4 times 5, right? I mean, you could break it down to its primes, but there's no need to do that. Just write 4 times 5. So the square root of 4 is 2, right? Done with that. And then the square root of 5. So that's your denominator for this. So let's write them out. So that's the first one. We don't mess with that one at all. This one, we keep the numerator the same, and this is 2 square root of 5. See how they rigged these? They didn't just put random numbers down here, did they? They made them so that you'll get a square root of 5 down here. Now, they don't necessarily have to do that, but it seems like they do that quite a bit. Minus 3 over, let's take square root of 45. Again, this is something at this point in your career, math career, you should be able to do this in your head. So think 45. What times what? There's a couple things that are 45, but I would use 9 times 5, wouldn't you? All right, the square root of 9 is 3, and then square root of 5. Okay, that should be something everybody in here does fairly easily. All right, so you might actually just be able to go from here to here without doing all this stuff over here. All right, hopefully you're at that point where you can. All right, now we take a look at this. Now we deal with the fractions. All right, now we can find a common denominator. Remember we talked about this yesterday? This is kind of like 1x and 2x and 3x, isn't it? All right, so our denominator, I always like to put it over one common denominator. I guess you could split them up into 3 different fractions like this, but in algebra, it seems we have a tendency to put it over one common denominator. So I've got a 1, a 2, and a 3. What would be my common denominator with 1, 2, and 3? That would be 6. Now look, they all have a square root of 5 in it, right? And it only shows up once, right? The square root of 5. So I'm going to use just one of them. So it's 6 square root of 5. It's just like if it was 1x, 2x, 3x, what would your common denominator be? 6x, right? But it's not an x, it's a square root of 5, but we kind of treat it the same way. All right, so that wasn't so bad. After we simplified them, the common denominator was actually pretty easy. Let's find the numerator now. So let's take this. What did we multiply this by in order to get to our new denominator? Multiplied it by 6. So if you multiply this by 6, right, then you have to multiply the top by 6 as well. So I get a 6 up here. Do the same thing here. What did we multiply this by to get our denominator? Just a 3, right? 2 times 3. So if you multiply this by 3, then you have to multiply the top by 3, and that gives you a 12. And we've talked about this before. Why do you have to do it to the top and the bottom? Because it becomes a what? A 1. And you can multiply anything by 1, and it doesn't change the value of it. That's why we do that, okay? What about this one? What do we multiply this by to get to 6 square root of 5? Just a 2. So you multiply that by 2, and so you have to multiply the top by 2 as well. And that's just a 6. All right? What do we got? You could go 6 plus 12, but I see 6 minus 6 is 0, plus 12 is what? 12. Over 6 square root of 5. I see something else I can do, don't you? Yeah, simplify. That goes once, that goes twice. So I've got 2 over the square root of 5. Do I circle that? Am I done? Nah, because it says simplify the expression. Technically, that's not simplified. Remember, because you have a square root in the bottom. So what do we have to do? What's that phrase that we use? Real fancy math word.
Rationalize.
Rationalize. In this case, the what? The denominator, okay? Because if they don't tell you one way or the other, if all they say is simplify, they expect you to get rid of the square root or any root in the denominator. So they expect you to rationalize the denominator, even though they might not say it. I've had kids before write it like this on the quiz, and I mark it wrong. I'm like, no, simplify, rationalize the denominator. And you're like, well, you didn't tell us we had to do that. No, I did many, many times in class, right? It might have not said it on the test, okay, but I'm telling you right now, this will be incorrect. It'll be wrong, right? Because my instructions to you are to rationalize the denominator. Now, in the real life world, if you were to do something, get an answer like this, in the real life world, I would probably put it into a calculator, get some decimal number, right? So really, in the real life world, rationalizing the denominator is not that big of a deal. You don't really have to do that. In fact, I've talked to Mr. Jackson about it. I asked him, like, why do they always make you rationalize the denominator? You know, what's the purpose in that? I never really understood what the purpose in that was. I still don't really understand it. And he's like, you know what? He says, you're right. He says, in fact, he says in his classes, when he's like in physics and things like that, he says, at this point, just leave it like that. Who cares? But I'm telling you, I'm trying to prepare you for a college class that you might take next year, and you might have professors that make you rationalize the denominator. So I want you to at least know how to do it, right? Whether or not it's a good practical thing to be able to do and there's a good reason for it, you know, there may not be. But if anything else, you'll at least know how to do it if your professor next year makes you do it. So how do we do it? In this case, we just multiply top and bottom by the square root of 5 so that we get rid of that square root. Change my colors again. So let's multiply this together. Multiply the top, it's 2 square root of 5. Multiply the bottom, square root of 5 times square root of 5 is just plain old 5. And that's your answer right there. So that's really the only acceptable answer that I'll take if that was on a quiz or a test. Okay? So make sure that you do that. What's that? Today's date is the 8th. All right. We okay with that one? I mean, it's a few steps. It wasn't that bad, though, was it? Look, you simplify those, find a common denominator, simplify the fraction, and you're done. All right, let's do another one. I'm going orange yet today. Let's do that one. What was the other one? 7? Is that what you said? Okay. We did one just like this yesterday, didn't we? Doesn't it look exactly the same, except the numbers are just a little bit different? I mean, I think even the letters are the same, aren't they? Didn't we use P and Q yesterday? Yep. So I would have hoped, maybe just made a little calculation error, but I think the whole idea how to do this problem, we did it yesterday. I told you to write it down. So hopefully you went back and you looked at what we did yesterday, okay? Because I let you hang on to that homework too, didn't I? Right? Yep, to use it to help you out with this. All right. So here we go. Let's see what we can do here. Actually, I'm not going to put an equal sign. Why is this not simplified? It says to simplify it, doesn't it? And it says to rationalize the denominator. Why is the denominator not rationalized, as they say? Well, because you got a square root down here. You can't have it like that. So you want to get rid of the square root. Now, this is not just as simple as the other one where I just multiply by a square root. This is part of a sum, isn't it? It's 8 plus the square root. So we learned a little method a couple days ago about simplifying this when it's a sum. And what's the fancy math word that we used?
Conjugate.
It's the conjugate. It's the multiplying by the conjugate. That's right. So let's multiply by the conjugate. Hopefully you know what the conjugate is. If you don't, you haven't done enough. All right? All right? We've talked about conjugate quite a while, and you got to look that stuff up. So you need to know the words. Know the vocab. Know how to speak the language that we're speaking here. So this is the conjugate, right? I'm going to do this. I'm going to put parentheses around these two because they are being multiplied. They're sums and they're being multiplied, so I always put those sums in parentheses if I'm multiplying them together. All right? Now, I can't just do that to the bottom. I also have to do it to the top. And again, we talked about this already today. The reason that I do it to the top and the bottom, so it makes a 1 and I can multiply by 1 and it doesn't change the value of it at all. Let's keep going. Let's just do it down here. I always like to do the bottom one first because basically it's a difference of 2 squares. So all we got to do is multiply the first and the last together. So let's do that. 8 times 8 is 64. Positive times a negative is negative. And now watch, this square root, it looks like it's complicated, but it's actually very, very easy. If I take the square root and multiply it by the same exact thing, another square root, basically what just happens here? what are we left with? Just the p plus q, just the stuff inside the square root, okay? So when I multiply a square root by itself, the square root basically just cancels out, and I'm just left with what's underneath of the square root. Now, but you got to be careful, though, because you're left with a p plus q. Can I just write it like that? I can't, because I'm not just subtracting the p. What am I subtracting?
The q.
The p and the q. All right, so it has to be in parentheses. That's very, very important right there. We mentioned that yesterday too, didn't we? Okay, all this stuff. Now, I didn't record yesterday, but I bet you if I did, and you pushed the recording from today and the recording from yesterday, I'm saying the same exact things. I don't know any better way to explain it. All right, so hopefully you're catching on to one of these explanations. Now let's take the top and multiply them together. So I got to distribute. See, that's why I put this in parentheses, because you have a sum. You have a minus right there. So this 4p is being multiplied by both of the things inside of here. So we got to multiply them both. So 8 times 4 is 32, and then a p. And now I got a minus. Then it's 4p times the square root of p plus q. And it's almost done, right? That almost looks like the answer that I read off. I'll write it all out. I was going to just erase this bottom one and change it, but yeah, we'll just write it like this. 4 square root p plus q. They didn't factor out a 4 here, did they, on the answer? Yeah, I didn't think so, because there would be no real reason to do that. Because 4 does go into 4 and 32, doesn't it? Yeah, it does. But there's no reason to factor out the 4 because there's nothing that will cancel out with the bottom because they're all sums down the bottom. So I would just leave it just like that. Is that how I read off the answer to you? Yep, that's exactly how I read it off. Nope, keep it like that. This is how I want you to keep it. I want you to keep it just like that. All right? All right, what's the next one? Was that 11 or something like that? Or 9? My memory's horrible. What color haven't we used? Anything interesting? Let's use this ugly tan. Cappuccino is what they call it. Look at that. Cappuccino. Alright. 9. So it's a cube root. Actually, let's make that cube root a little bit higher because we're going to stick a fraction inside of there, aren't we? Alright. It's 3 over 5. I don't like to write that diagonal division line. I like to put it horizontal like that. Okay, there's been a few times where I've taught like younger math classes and we've done fractions and stuff, and I always try to get them away from writing it like that, especially when you're doing stuff with them, when you're adding fractions or you're multiplying. Okay, that's way too confusing. I would never write a fraction like that. Okay, so let's do it like this. This makes much more sense. So watch what we're going to do. We're going to take the cube root of 3 and put it over the cube root of 5. And look at the question. Number 9 says, rationalize the what? Read the instructions. What's it? The numerator. So this is a little different, isn't it? It's a little different than they normally ask. Okay. Again, it's kind of rare. I hardly ever remember other books asking you to rationalize the numerator. But in this book, they do. So it's not that big of a deal. So let's rationalize the numerator. So that means we have to get rid of this root in the numerator. Now this one's a little bit trickier because this is 3 to the first, isn't it? So I can't just multiply by a cube root of 3 to the first because it's not good. If you multiply them together, it doesn't get rid of the cube root. But I'm going to multiply it. Actually, if you could do the evens on that worksheet. Okay, that's what I'm going to assign tonight. So watch this. I'm going to put the cube root of, now what do I need in here to cancel out the cube root? I need a what? Well, you're right. I do need a 3 squared because eventually when I multiply them together, I need the cube root of 3 cubed, right? You follow me? So in order to make this a 3 cubed, I got to multiply by 3 squared, okay? So 3 to the first times 3 squared is what? 3 cubed. Everybody see that? And it's inside the cube root, so it'll cancel out the cube root, and that's the whole idea. That's what I wanted to do. So now I do the same thing here. The cube root of 3 squared. So let's see what we get. Now the whole idea of us doing this right here was to get 3 to the first times 3 to the second. That is 3 to the third. And the reason I want it 3 to the third is so that that cube root and that cube cancel each other out. You see what I'm trying to do here? That's why I multiplied by 3 squared. because 3 to the first times 3 squared is 3 cubed. Now let's multiply the bottom. They're both cube roots, so I can just multiply this stuff together. Well, 3 squared, what's 3 squared? That's 9. 9 times 5 is 45. Okay? And I can't simplify that because 3 is 3 times 3 times 5. I can't group anything into groups of 3, so I know that that's simplified. Okay? And let's do one more thing to make this a little nicer. The cube root and the cube, they cancel each other out. So on the top, I'm just left with a 3. And on the bottom, I have the cube root of 45. Now you look at this and you say, wait a minute, that can't be the right answer because you got a cube root. You got a root on the bottom. I thought you said, Mr. Hamrick, you can't have roots on the bottom. But what were the instructions to this problem? To rationalize the what? The numerator, okay? So, in this particular problem, it's okay to have a root in the denominator. Why? Because the problem specifically asked to rationalize the numerator. Make sense? So don't get confused on that. I think I've explained that pretty well. So don't, on a quiz tomorrow, if I ask you, I don't even know if I ask you to rationalize the numerator or not, to tell you the truth. But that's what that answer would look like right there. Well, I think we covered everything, didn't we? All the questions you have. Now, what I'd like you to do, just for more practice, and the more practice you have, the better, okay? We've gone through this twice now. This will be your third time going through these style of problems, okay? So you really should be able to get these right. So I'm going to have you do that section 1.7a and b. They're all review. So it's the same worksheet you're working on. We're just going to do the evens this time, all right? So do the evens. And that's it. And we are going to have a quiz tomorrow. And we've got a couple minutes left. Let me go grab the quiz and just kind of see if we've covered everything and see how many problems there are and all that kind of stuff. Okay?